Question number 7. You are a little boy or girl and stole your parents' hot air balloon. You are also a thirsty kid and brought some cans of soda. Each can holds about 354 milliliters. As you get higher in altitude, you notice that your soda cans start to expand and then eventually explode. You are now thirsty and desperate to figure out what happened. You find out that the pressure at sea level is 1 atmosphere, and where the cans exploded was 0.7 atmosphere. You also note that at sea level, the temperature is 30 degrees Celsius and 25 degrees Celsius where the cans exploded. Why did the cans explode? So for this question, we can kind of just theorize what happened before actually doing any calculations. So let's look at the ideal gas equation, PV equals nRT. Okay, so the cans exploded because the volume of the liquid expanded, and so the can could no longer hold that volume. So why would the volume expand? Well, the pressure at sea level is higher than at a higher altitude, right? Pressure decreases as you go higher up. So if you look at this equation, pressure and volume are inversely related. So as pressure decreases, then volume increases. There's a small change in temperature, but that's not going to be as significant as the change in pressure. Okay, so pressure decreased, volume increased, the can was too small to hold the expanding liquid, the can exploded. So let's prove this in mathematical terms. Okay, so at sea level, we need to first determine the number of moles of the liquid. Okay, so the number of moles is constant regardless at any altitude, any pressure, any temperature, because it's the number of moles of liquid in the can. Okay, so to determine the number of moles, we do PV over RT. Okay, so the pressure at sea level is 1 atmosphere. The volume is 0.34. The 0.354 liters times 0.08. And the temperature, this is where you have to be careful. So the temperature at sea level is 30 degrees Celsius. So we need to convert that to kelvins. So 373 plus 30 degrees is 333 kelvins. Okay, so multiply by 333. That will give us 0.014 moles of the liquid, of the soda. Okay, so now we can determine what the pressure what the volume was at the higher altitude. So at higher altitude, okay, so at higher altitude, to determine the volume, we can do nRT over P. So the number of moles is constant times 0.08. So again, here you have to watch out for the temperature. So the temperature is 25 degrees Celsius, so we have to do a conversion. So 298. Over 0.7 atmospheres, right? So this gives us about 0.489 liters. Okay, so that's 489 milliliters. So the original volume was 354 milliliters. It expanded to 489 milliliters, so therefore the can exploded. So we made sense of this question just by looking at the ideal gas equation, and then we proved that using a mathematically.